we have this positive feedback loop going on, because the more economic bandwidth we have, the more decentralized stablecoins we have, the more economic activity we have, the stronger the selling points become of scarcity and security. There is going to be, in my opinion, one asset that's going to win the beauty contest, basically, of being the most attractive asset. And right now, Ether, the asset, is the number one, contender to winning this beauty contest.
Welcome to Bankless, where we explore the frontier of internet money and internet finance. This is how to get started, how to get better, and how to front run the opportunity. This is Ryan Sean Adams, and I'm here with David Hoffman, and we're here to help you become more bankless. Did you know, Bankless listener, that in the not too distant future, it's likely, not 100%, but very likely that Ethereum is going to get yet another economic upgrade that will burn even more ETH? David, did you know that before this episode?
I do now.
I mean, we learned a lot in this episode. This is going to be the biggest potential upgrade to ETH since EIP1559, at least when it comes to the burn. Of course, you remember EIP1559. We talked about it a lot on Bankless in the days before the burn and in the days after the burn, but that was the first of two potential burns that are coming. We're going to talk about the second today. This is called the MEV Burn, and the guests today call this Ethereum's second business model. Few things we're going to cover. Number one, why MEV, that is maximal extractable value, is so annoying to protocol devs. Number two, why ETH is not only money, but it's also like oil. Justin uses the analogy of crude oil and petroleum and jet fuel. You'll find out what that means. Number three, why Justin Drake says all validators are losers, but there's a way we can fix it. And number four, we talk about this metaphor, birds, bread, and MEV burn. What do they all have in common? What is Ethereum's second business model? David, just when you thought you couldn't learn more about Ether and the economic potential, you couldn't get more bullish on Ether, the asset, of course, Justin Drake comes in with another episode. This time he's accompanied by another protocol dev whose name is Dom. David, why is this episode so significant?
This episode is going to apply a lot of previous Bankless content. So we are going to layer on the lessons here in this episode. And I think we did a pretty good job of referencing those lessons that we talk about in the episode. So some previous episodes that we are going to need for the Bankless listener in order to understand the episodes about EIP1559, either with Justin Drake in the Ultrasound Money episode or the one that we did about EIP1559 with Hazu. Understanding EIP1559 as a mechanism will be a core building block for this. Also, Matt Cutler's blockchain supply chain, how a block comes to be mined on Ethereum or minted on Ethereum, which leads into the conversation of proposer-builder separation. There's a lot of pre-existing knowledge that culminates in this new upcoming EIP. I don't think we have a number for this yet, but this new protocol change to Ethereum what Justin and Dom say is a logical continuation of EIP1559. And so there are two main patterns, two main mechanisms of EIP1559 that are being continued. One about EIP1559 is that it actually places an oracle of Ethereum into itself. What do I mean by that? Through EIP1559, Ethereum is actually able to see how much block space is being demanded. It is providing itself with information about how much demand there is for its own block space. And through that mechanism, EIP1559 allows Ethereum to price itself, a very important mechanism. And then, of course, the second is the burn. These two mechanisms are being extended here in MEV Burn to great benefit for many different parties in the Ethereum ecosystem, but primarily the ETH holder. And so really the significance here is about the economics of Ether. And the other thing to pay attention to is this part of the conversation where we focus on how Ether is actually the most decentralized part of that stack. And so the choice to place emphasis on Ether is a choice in decentralization. So these, I would say, are the themes of the episode to really pay attention to. And if the Bankless listener needs to pause and go acquire some knowledge from other Bankless podcasts before diving into this one, I would definitely recommend you to do that because they are all very valuable podcasts.
Yeah, I would definitely say this is maybe 300 level content. And, we thought we were going to do one Ultrasound Money episode with Justin Drake, but it turns out This is like the ultrasound money never stops because we keep improving the protocol.
Only
So if
gets more ultrasound.
I mean, if you're curious about what this MEV burn is, how much ETH per year it might burn, Justin Drake comes in with numbers, so he's got estimates of that. When is it coming? We have all of that information in the podcast. And David, I am super excited to actually do the debrief with you after this episode because I learned some things about Ethereum I didn't know. And I want to pick your brain about those. So, of course, our debrief episode is the episode we record right after the episode. It's on the Bankless premium feed. You can access that if you're a Bankless citizen. And some citizens have told me recently that this is actually their favorite part of the Bankless podcast. Even some of the episodes, they're just like, the episode
rough,
was good.
Uncut, no agenda, no curation.
Like,
sometimes we don't even talk about the episode.
I know. We kind of ramble and people enjoy that. But like maybe the debrief is for you. Maybe that's a good addendum to the episode. Anyway, that is available for you. Click the link in the show notes to upgrade. Guys, we're going to get to our episode with Justin and Dom on MEV Burn. But before we do, we want to thank the sponsors that made this possible, including our number one recommended crypto exchange. That is, of course, the one, the only KRAKEN. Go check it out.
KRAKEN Pro has easily become the best crypto trading platform in the industry. The place I use to check the charts and the crypto prices, even when I'm not looking to place a trade. On KRAKEN Pro, you'll have access to advanced charting tools, real-time market data, and lightning-fast trade execution, all inside their spiffy new modular interface. KRAKEN's new customizable modular layout lets you tailor your trading experience to suit your needs. Pick and choose your favorite modules and place them anywhere you want in your screen. With KRAKEN Pro, you have that power. Whether you are a seasoned pro or just starting out, join thousands of traders who trust KRAKEN Pro for their crypto trading needs. Visit pro.kraken.com to get started today.
You know Uniswap, it's the world's largest decentralized exchange with over $1.4 trillion in trading volume. You know this because we talk about it endlessly on Bankless. It's Uniswap, but Uniswap is becoming so much more. Uniswap Labs just released the Uniswap mobile wallet for iOS, the newest, easiest way to trade tokens on the go. With the Uniswap wallet, you can easily create or import a new wallet, buy crypto on any available exchange with your debit card with extremely low fiat on-ramp fees, and you can seamlessly swap on Mainnet, Polygon, Arbitrum, and Optimism. On the Uniswap mobile wallet, you can store and display your beautiful NFTs, and you can also explore Web3 with the in-app search features, market leaderboards, and price charts, or use Wallet Connect to connect to any Web3 application. So you can now go directly to DeFi with the Uniswap mobile wallet. Safe, simple custody from the most trusted team in DeFi. Download the Uniswap wallet today on iOS. There's a link in the show notes. Bankless Nation, I would like to introduce you to Justin Drake. He is a cryptographic meme lord, a researcher at the Ethereum Foundation, and creator of ultrasound.money, a website that illustrates the metrics and data around the world's most interesting financial asset, ETH. Justin has helped the Bankless Nation navigate the world of cryptography, crypto economics, and today he returns to Bankless with a brand new course of study to teach us, this time in the world of MEV. Justin, welcome back to Bankless.
Thanks for having me again.
We also have Dom, aka Domothy, the Robin to Justin's Batman, also a researcher at the Ethereum Foundation and has a comfy seat aboard the ultrasound train as well. He's also played a big role in today's subject behind MEV Burn research. Dom, welcome to Bankless for the first time. It's an honor to have you.
Yeah, I'm happy to be here.
I'm really excited for this conversation, especially when Justin gave me the line that MEV Burn is simply the logical continuation of EIP1559. We've got a great conversation mapped out for you, Bankless Nation. But first, I think we really need to start at the highest of levels before we map out that conversation, just so we can set the stage. Justin, what is MEV Burn?
Okay, so MEV Burn is a very simple idea. It's this idea that all the excess MEV that's being generated on Ethereum that is currently going to proposers through what are called MEV spikes no longer go to the proposers in the form of MEV spikes. Instead, these spikes get kind of smoothed out. And so that's one aspect of MEV Burn, is this smoothing of the spikes. And then the second aspect is the redistribution, meaning that the ETH is burnt and it's essentially redistributed to all the ETH holders.
Justin, can we really quick, for people who even MEV was too much for them, I think we have to define what this acronym actually means. MEV. So if you're deep in the crypto weeds, you've probably heard crypto folks talk about this a lot in different contexts. Can you define what MEV is for us and tell us why it's important? Why are crypto people always talking about this acronym, MEV?
Right. So MEV stands for maximal extractable value. It's basically the value that can be extracted by the participants that are running some sort of economic system from the participants, the activity on top of that economic system. So in the case of Ethereum, we have a blockchain, that's the economic system. The participants behind it are the proposers, the attesters, the block builders, the searchers, etc. And the activity is transactions. And it turns out that these participants that are making Ethereum move forward block by block have the opportunity to extract value from the transactions. Now, I'd kind of distinguish two forms of MEV. One is what I call congestion fees, is the more people want to use the chain, the more you have to pay in terms of base fees for EIP1559. And that is the most common use of Ethereum, and it leads to, again, these so-called congestion fees. But there is a second thing going on, which is contention. So sometimes you don't only care about getting your transaction confirmed, getting your transaction included on chain, you also care about specific ordering. And this is for very sophisticated actors, for example, arbitrageurs that, for example, want to be at the very top of the block. And it turns out that what EIP1559 did is that it took these congestion fees that were previously going to the consensus participants, to the proposers, and now it's giving it to the system itself, to the ETH holders. And what MEV Burn is all about is basically continuing the story of EIP1559, but for contention. And so now, we have this potential opportunity to have two separate business models for Ethereum, both in terms of revenue from congestion fees, but also revenue from contention. And it's not just about all sorts of economic advantages that we get from that, but there's also security benefits from the smoothing that I was talking about. So,
Justin, we're definitely going to talk about the smoothing and the security benefits and all of those things. But really quickly, while we're still on the topic of MEV, and Bankless listeners, there's a library. There's a library of previous MEV episodes if you still need to catch up on MEV itself. But just the Ethereum posture from a protocol perspective on MEV, what is MEV? Is it good? Is it bad? Is it something we're trying to squeeze out of the system? Is it something we're trying to harness and manage? Trying to form an opinion on MEV, if it's good or if it's evil.
Right. So MEV just is. It's an emergent behavior. So it's something that emerges from the economic activity on top of this economic system. And from the perspective of a protocol designer, it's kind of annoying. And the reason it's annoying is because it distorts the incentives that we put in place, right? So we have these crypto economic incentives. For example, issuance is this thing that we control as a designer of a blockchain. And the MEV comes and distorts these incentives. And so on the one hand, from the perspective of the protocol, we kind of want to tame and we want to mitigate the MEV. But it turns out that not only can we mitigate some of these negative externalities of MEV, but we can actually embrace them, we can harness them, and MEV can actually make Ethereum stronger. It can provide more economic security, it can provide more economic bandwidth, and ultimately it can help Ethereum succeed in its mission of becoming a settlement layer for the Internet of Value.
So as a podcaster, one of the reasons why I love doing podcasts with Justin Drake is because he provides very robust agendas, which makes my job very, very easy. So Justin, we've got 4 parts that we're going to walk through. Just part 0, the intro, setting the stage. Part 1, the mental model, congestion and contention, which you've already established. And then after this, we go into smoothing, which are talking about the security benefits for Ethereum, and then redistribution, which are the economic benefits. And so the way I see this conversation going forward is we're just going to start to set the stage, continue to define some terms a little bit, and then we're going to really unpack that mental model of what Justin calls congestion versus contention. And both of these are block space demand, but one is just congestion is just like basal block space demand, the average transaction, and then contention is the demand to be first in a block. And these different demands have different properties. Smoothing is MEV smoothing, and redistribution is MEV burn, redistributing it to all ETH holders. But Dom, I'm wondering, where do you fit inside of this conversation? Where have you specialized? What's your role here when you do a lot of the Ethereum research? What are you specifically researching, and what should we know before we go through this conversation?
Yeah, I'm mostly interested in the way we quantify MEV. We're working with the auction model or having proposers like impose their view of bids from block builders. So this is like step one of MEV burn is actually quantifying the bids, and because MEV is very subjective when you think about it, like an arbitrager putting a transaction first in the block to extract like 1 ETH from like 2 different decentralized exchanges. That's not something the protocol can be aware of because that's all application level stuff. So we have to use the subjective view of block builders and how much they're willing to bribe proposers. And if we can ensure that in the protocol, then that's a way for the protocol to be aware of what's going on, like the most objectively it can, even though it's still application level. And once we have this way of establishing the bids in the protocol, then we can proceed to the burn and doing whatever we want with it. The same way EIP1559 has this on-chain oracle for the base fee. This is what we want for MEV.
This makes me really excited because one of the beautiful things I think that got a lot of the Ethereum community excited about MEV was the elegance in the mechanism of actually being able to instantiate what is the market rate for gas on chain, so that now that kind of becomes like an on-chain oracle of sorts. Like the Ethereum protocol knows something about itself because of EIP1559. And that thing is, what is the net demand for my block space? That it becomes an output that is what the output of EIP1559, the mechanism, is. And I think what you're saying is that we've got this new mechanism. And this new mechanism actually allows the Ethereum protocol to come up with some quantification of what the level of MEV is going on top of it. Is that my understanding, Dom?
Yes. It's all cool. External demand that the protocol can be aware of, and then do whatever we want with it and tweak the incentives for security and economic properties, which is all exciting stuff.
And this is a really important part of this conversation, because when we talk about the two things that are downstream of that, the smoothing and the redistribution, it first starts with understanding how the Ethereum protocol actually quantifies MEV, because we need to know how much to burn and how much to smooth, correct?
Yes.
Okay, cool. All right. So where should we start here? Justin, do we have any more definitions that we need to get through before we get to congestion and contention?
I mean, on the topic of congestion and contention, I kind of have this metaphor that I came up with this morning. Let's see how well it sticks. So I kind of think of three forms of oil for Ether, the asset. So there's kind of crude oil, which is the unrefined format, and this is what you're holding in your wallet in large quantities, in barrels and barrels of oil, stored in cold storage, and you're not using on a regular basis. And then you have this more refined form of oil, which is petroleum, that you use on a day-to-day basis to go drive your kids to school or to go to the grocery store. And what happens there is that basically you take a few liters of crude oil, and then there's this digital refining process which turns it into petroleum, and then you go burn it. And this petroleum can go in like most engines for most transactions. So that's the transaction base fee that gets burnt. And now basically MEV is this ultra refined type of oil, is this high octane rocket fuel, jet fuel, or Formula One fuel that is used to fuel a very sophisticated engine, which is this MEV engine, which has these very high performance pistons that are driven by searchers and builders. And really what MEV Burn is all about is about recognizing that there's this ultra refined form of oil that you can harness to improve Ethereum's security, Ethereum's economic bandwidth, that Ethereum itself as a system can be aware of and can have an oracle for MEV. And not only that, but we can remove a lot of negative externalities from kind of leaving this on this super refined oil just explode nilly-willy and potentially affect chain stability.
Okay, so to put that, I really like that metaphor. So like the average consumer, the average operator of a combustion engine uses the average gas. And when I send Ether from davidhoffman.eth to ryanseanadams.eth, that's actually not Ryan's Ether ENS name, I just use normal oil. And that's fine. That's great. That's what I need to do to get from point A to point B. What you're saying is like the contention part of a block, which is that first slot in the block, is a insanely efficient place in the block because of this, what you're calling an engine, because the reason why you're using that word is because you're looking at the MEV landscape as a system as a whole. We have transactions, and then we have transaction bundlers, searchers who search through the transactions to make a bundle, and that bundle gets conversion to a larger bundle, and that ultimately becomes a block. And we have MEV bots, we have liquidation bots, we have people that are micro arbitraging Uniswap, we have everything, all the MEV that's all happening, a massive industry, and they're all fighting for that one block. That one slot that in the block, the top transaction slot, because that is where they fight for. They fight for all of that economic activity. And you're saying that one slot consumes MEV, consumes Ether to get into that one slot, and as just a highly refined version of Ether. Even though it's the same Ether that we all use, it's still highly refined because of the net output of that one slot is this massive explosion of economic activity inside of that one block. That's the metaphor, correct?
Right, that's correct.
So Ether is oil. Ether's not only, it's money to purchase oil, I suppose.
And then there's the flip side, which is just congestion. But I think that's not the subject of this podcast. That was the subject of our older podcast that was just about EIP1559, right? So this podcast about MEV Burn is just primarily about the activity in the contention part of the block space, correct?
Right, that's correct.
Okay, so we've defined congestion. We've defined contention as well. Congestion is sort of the basal level of block space demand. That was EIP1559. It burnt that. Now we have contention, which is the desire to be the number one transaction. And any MEV burning is going to solve this. I'm wondering if you could get us to the higher level, because in the next part, we're going to talk a little bit about smoothing and redistribution, so the actual burning of MEV itself. But why are we doing this in the first place? Like, what problem is MEV smoothing and burning actually trying to solve? Justin, you were talking about earlier that the desire of the protocol, as a protocol researcher, MEV is this annoying thing that we have to tame at the protocol level. So MEV smoothing and the burn is one way to sort of tame MEV. But describe to us, what problems are we actually trying to solve at the highest level here as we get into these next sections?
Right, that's exactly right, Ryan. So when I first came into this problem, I was trying to fix some of the negative externalities of what I called MEV spikes. What is an MEV spike? It's basically when you get randomly chosen as a proposer and you receive some unknown amount of MEV. It could be a very small amount of MEV. It could be like 0.01 ETH, or it could be a massive block. It could be hundreds of ETH of MEV. So you participate in this lottery, and that's why we say it's spiky, because there's these big spikes and the small spikes. Now, what are some of the negative externalities of MEV spikes? Well, one of the first ones is this chain instability. So the metaphor that I have in my mind is you have a piece of bread and you throw it in the park or you throw it in the pond. And then you have like ducks fighting for it, or birds fighting for it, or
MEV
fish
bots,
fighting for it. Yeah. And it's complete chaos. And it's a lottery because, if you throw the bread slightly to the right, then, this bird gets it. And if it's slightly to the left, this other bird gets it. And it's just
Justin is
complete
clearly from Britain.
I used to do this all the time. You didn't do this, David? I would always target that one bird or that one duck that seemed a little weaker than the rest and try to throw the bread directly in front of that one.
The benevolent MEV bot?
Yeah, that's what I tried to do. Sorry, I love this metaphor, Justin. Continue, please.
And what it means in practice is that there's these various participants that try all sorts of attacks. So they're going to try DDoSing each other. They're going to try Eclipse attacks. They're going to try chain reorgs and proposer equivocations. And they're going to try anything to basically catch the MEV. And that's
so some birds have teeth and claws that the other birds just don't got.
Yeah, exactly. You're incentivizing people to come in with their teeth and their claws and their guns to try and hit each other. But, if there isn't a reward, we don't need to be hitting each other. We can all live in peace and have a stable chain. And like one maybe vivid example is what happened historically with Binance. Binance got hacked for many hundreds of ETH. Of Bitcoin. It was I forget the exact amount. And one of the things that they were considering doing is revealing the private keys for those Bitcoin, thereby incentivizing the miners to go back in time to reorg the chain and to basically fight the attacker, take a cut for themselves, and return the bulk to Binance. And the Bitcoin community was very scared about this because it would lead to potentially massive chain instability. Now, the good thing is that if an equivalent scenario happened, Binance was hacked, but this time it was ETH, not BTC, and we had MEV Burn, then the mere fact of releasing these public keys would effectively burn all the ETH. And so there wouldn't be anything to fight over. So,
And this goes back to, I think, when I was just first trying to wrap my head around MEV, a very clear articulation of why MEV can be fundamentally bad. Like small, minute instances of MEV, like you said, Justin, just is. But from a chain stability perspective, they can be massively chaotic. And I think that the simple example is that Ether, just to use nice round numbers, Ether every single block, Ethereum every single block issues 2 Ether per block as reward. And then there's MEV, like gas fees on top of that. And because of DeFi and smart contracts, we have these opportunities that oftentimes can be much larger than the value of a single block. And so if the rewards for mining a particular block are like 10 ETH and Ethereum is only issuing 2 ETH per block, then that block that has a 10 ETH reward isn't actually considered secure until there's 10 more ETH issued in block rewards for the next corresponding blocks to lock that value into the chain. And so if a very large block gets mined, and sometimes we've seen blocks in the Ethereum world get mined that are like 60 to 100 Ether. And so you can't really consider these blocks finalized until there's a sufficient level of economic weight in front of those blocks to like embed the big blocks into the chain. And this was like the original way to understand the dangers of MEV. And so this is a mechanism, Justin, what you're saying, MEV burn and smoothing, that directly goes after this phenomenon, which takes MEV spikes and smooths it out, and hence MEV smoothing.
Right. I mean, this is especially true with Bitcoin, where they only have proposers, not attesters. And so if there's a very, very large bounty to go back in time, then you need to take these bounties into account in addition to the issuance. In Ethereum, we have this other mechanism where the attesters come in and they provide economic weight and they don't really have a dog in the fight, and so they're a little bit more neutral. And so Ethereum, will converge, eventually, even if there is like this big MEV spike, but kind of locally it could lead to these chain instabilities, which are
Justin, back to the bird analogy. Rather than just throw one big hunk of bird and then watch how the birds kind of fight, what you're doing with MEV smoothing is you're just dividing that chunk of bread into all of these bitty pieces, and you're somehow letting all of the birds take it at once. And I guess maybe the birds
are just being a bird.
Yeah. You're just, and so that feels very nice. That feels very egalitarian. It feels like the, some of the weaker birds actually get a shot at getting fed rather than the big birds with, the teeth and, just plowing their way to the front don't get all of the food. That would make childhood me very happy if I had that sort of protocol in bread distribution.
And just to be really specific, the weaker birds are the lower capitalized hobbyist solo stakers. And then the big birds with guns and teeth and claws are like the data center birds that have fiber optic connections, just to make that extremely specific. So Dom, I think this conversation now needs to turn to how MEV smoothing and burn actually happens. And this is, I think, where your role and your research at the Ethereum Foundation starts to play in here, because we're going back to like, the protocol, Ethereum, the protocol needs to do this autonomously. Therefore, the Ethereum protocol needs to be able to measure the size of the breadcrumbs that are being thrown out to all of the validator birds. So can you walk us through that process? How does the Ethereum protocol come to understand the size of the bread? Man, I love this metaphor.
Right. So today there's no mechanism for that at all. All the MEV, we would need proposer builder separation enshrined in the protocol, because today we have MEV Boost, which has this PBS but out of protocol, with the relays acting as the brokers to receive bids between builders and relay them to proposers, and then brokering the relationship and having all the trust to them. But what we wouldn't want is enshrined PBS for not only removing this trust and having a fully trustless and unconditional payment between builders and proposers, but also having the protocol be aware of the bids. So one way to do that, well, first there's all these designs proposed for enshrined PBS, which is the first step for MEV Burn. And there are a few mechanisms to do that, one of which is having simply bids be a part of the beacon chain, having a structure for where builders are supposed to send their bids, instead of relying on external protocol like MEV Boost. And once we have that, then we can have the attesters impose their view of bids on the proposer, so that if they say they're all hearing builders bid 1 ETH, 2 ETH, and then the proposer says, okay, I'm going to bid 0, and then I'm going to just steal the MEV, then that's not going to work, because other attesters are just not going to vote for that block. So that's like one high-level overview of how we can have not only be aware of bids, but also impose this view on the proposer.
So Dom, are you saying that PBS, by the way, Bankless Nation, if you're not familiar with that term, it's not the broadcasting network in the US. PBS stands for Proposer Builder Separation. We've done entire episodes on this, and we will include links in the show notes to get you caught up. This is a future Ethereum protocol roadmap item that we've been wanting to achieve, and it's not going to happen this year. It's in the more distant future than this year. Protocol or proposer builder separation. Are you saying, Dom, that PBS, some version of it, is a requirement to get us to MEV burn and MEV smoothing that we're going to talk about in the rest of this episode? So
yes.
First things first, we need PBS at the protocol layer. We need to deploy that. Then we'll have visibility into the MEV. Is that what you just said?
Yes.
Got it. Okay. That's understood.
And I think the episode that we did with Matt Cutler from Block Native talked about the Ethereum blockchain supply chain, which is fun to say. And really the proposer builder separation, proposers are people who are proposing a block. That's Ether stakers. Justin, correct me if I'm wrong, but proposers and Ether stakers are largely synonymous. And then before that are the block builders. So instead of the Ether stakers, again, which we want the supply chain of the Ethereum blockchain to be maximally accessible to the average retail individual. So we've separated the role of building a block from the Ether stakers, and the block builders just compete by submitting bids to Ether stakers as to which block to propose. And so the proposers select the highest bid block because they want to be paid the most amount of Ether. And all of the very computationally intensive and high resource constraining role of building a block, putting all the transactions in the correct order, running all the computation to make sure you're maximizing MEV. All of that is done by a very specialized entity that's hard to compete with. But they just bid for block inclusion by Ether stakers. And I think, Dom, what you're saying is that through the process of proposer builder separation, and then also the earlier step of transaction bundling, there is a pseudo oracle process that is able to be contained step by step by step that ultimately becomes converged onto the actual block builder and block proposer. And because of each transaction inside of a block has a small amount of value associated with it, all of that gets aggregated into some sort of oracle that gets passed along to the block proposer, and the Ethereum blockchain actually can ingest that information and use that as an oracle. That was my best explanation at this.
Yeah. So what happens is that Enshrined PBS basically takes the bids and formalizes the notion of a bid in the beacon chain. So the beacon chain is aware of these values. So there's one value, one bid per block. It could be 10 ETH, could be 1 ETH, could be 0.1 ETH, whatever. Now, the question is, how do we know that this value that is on the beacon chain is real, that it reflects reality? Now, there's two things that could happen. One thing that could happen is that the value is like artificially high. Like someone says, okay, I have a bid of 1,000 ETH when there really isn't 1,000 ETH. And this is something that you can do today. Like I can create a transaction from myself to myself, as a proposer, and I put a 1,000 ETH kind of tip, and it's kind of a no-up because I'm spending 1,000 ETH, but then I immediately receive it as the proposer and the recipient of the tip. And what the burn does is that it makes it real in the sense that you're no longer incentivized to kind of cheat by artificially inflating the oracle. But then there's this other thing that you want to prevent is people artificially putting a low value of the bid, of the burn. And the way that you do that is you invoke the attesters. So anyone can observe this bid pool. In particular, the attesters can observe the bid pool. And if you pick a value of the bid which is too low, which is not the highest bid, then the attesters are just going to say, beep, your block is just not going to make it on chain. And so you lose any opportunity to build a block. So basically, we're enforcing the correctness of this bid value, the fact that it reflects reality as the highest paying bid, using the attesters. And now that we know that this is a true oracle value that reflects reality, we can go ahead and burn it.
I would say there's another parallel with 1559, the way that the congestion pricing is now enforced by the protocol itself. Because back in the day, we had mining pools that would they would have side contracts, or they would, since they're in control of the contents of the block, they could put in 0 GUI as gas fees and just have free transactions. But now with 1559, everyone else is just competing for that space, including the block builder himself. So they can still have side contracts and say you don't have to put a priority fee, but they still have to pay the base fee. Like someone somewhere in the chain has to pay the base fee. So this is the same idea with MEV Burn, is just to impose this contention pricing on everyone, including block builders and proposers, so that side contracts are not encouraged, and the shelling point is the protocol mechanism to capture most of the value.
This was a big part of EIP1559 as a topic of conversation. There was just early thought experiments about actually you could strip out Ether from being the native currency of Ethereum, because miners could just use fiat payments or stable coins as the currency of account. And EIP1559 just completely eliminated that by actually enshrining Ether as the enforced unit of currency to pay for transactions in Ethereum block space. And Dom, what you're saying is that this just now, because of this mechanism that we have, this pseudo oracle, if you will, to understand the measure of MEV, we can extend that functionality to enforcing economic activity to also be known and quantified and verified on chain. And so Ren and I like to put these systems into nation-state government and just nation-state law perspective sometimes. And governments want all economic activity to be in the light, right? There's black market activity, there's side dealings, there's untaxable economic activity, or not untaxable, but untaxed economic activity, black market activity in every single part of the world. And same thing with Ethereum in this particular world, where MEV people can route around the protocol and just do some back alley dealing to get blocks included. But now, Dom, what you're saying is that with this mechanism, we have a way to actually, Ethereum, the protocol has a way to actually measure the economic activity that's being expressed, and to put that into an oracle and say, you must pay at least this amount to have your block included. Am I on track here?
Yes.
David, you just reframed it. And so now I'm looking at Dom and Justin. I'm seeing IRS agents right here trying to tax all the transactions here. I mean, there's an element. That's a great metaphor, because there's definitely an element that's true. The protocol wants all of these black market off-chain sort of activities enshrined inside of the protocol, so it can be kind of measured, and so that the carrot and the stick incentive mechanisms that govern and make Ethereum work can actually be activated. So Bankless listener, I know we've talked about a lot of things, but I just want to put a few ideas in your mind here, right? Because we're deep in the protocol research field of things, right? You know EIP1559, okay? That is the protocol, the change, the upgrade to Ethereum that started burning Ethereum and helped solve the congestion issue, the basal level of block space demand. Now we have a more efficient mechanism for partitioning that out. We created this oracle, so block space, Ethereum becomes self-aware of how much block space is demanded and how much it's consuming. This does the same thing with contention. And remember, contention is that desire to be the number one transaction. So we are talking about, at the highest level, something on the order of importance of EIP1559. And if you were here, I think Bankless talked about EIP 1559 about for 2 years before it happened. That's how
too much. Some people would say too much.
That's how excited we were about it, because it enshrined ETH, it solved the auction mechanism, it made ETH more money. There were all of these fantastic properties. And so I want to get us to, that's the context though. That's how big this is. That's how important this is. I want to get back to defining smoothing and a redistribution of this MEV in a bit more detail. So remember our bird analogy, okay? So we're talking about, rather than throw large hunks of bread out to all of the birds and watching them fight, as fun as that is if you're a tortured individual as a child, we get to be much more egalitarian and fair, and we get to parcel all of that hunk of bread into all of these pieces and smooth it out across all of the birds, okay? Can you talk to us about the security benefits of this, Justin, right? So it feels nice. The birds all get fed and everyone's equal. That feels nice. But there's actually, I know you guys are protocol researchers, so you care most, not necessarily about the birds, that's important, but you care about the health of the network. You care about the upside benefit, the positive expected value. So give us the case, why does smoothing actually achieve greater economic security for Ethereum, Justin?
Right. Okay. Let's try and keep this analogy. We care about the health of the flock. Now, the first thing that it does to kind of give everyone an equal amount is that there's no more fighting, right? Everyone gets a fair share. No more fighting. The other advantage is that you remove the lottery aspect, and so there isn't winners and losers. And it turns out that on Ethereum today, almost every validator is a loser. And what do I mean by that? I mean that the median reward that you get is significantly lower than the average reward. And the reason is that every once in a while, there's this mega block that comes in. So the highest MEV block so far has been around 1,000 ETH. And so there's one person out there.
1,000 ETH?
Yes, it was almost 1,000 ETH.
What did they do to get that?
They were just lucky. They bought a lottery ticket by being a validator, and every once in a while we have this massive jackpot. And so this one validator, he has a huge amount of APR, whatever it is, 1,000% or 10,000%.
The entire loaf of bread here is what we're talking about.
And then everyone else who didn't get a cut of that 1,000 ETH is a loser. And it's just like when you're playing lottery, right? Everyone spends $1 buying the lottery ticket, and almost everyone loses the $1. But then there's this one guy who just happens to win, $100 million. And so right now we're all losers, and we're risking a situation where with Bitcoin mining. So there's this incredible statistic with Bitcoin mining is that if you buy a Bitcoin mining rig and you run it for 5 years, continuously plugged in, more likely than not, this mining rig will never produce a block. So it will never earn Bitcoin. And so Bitcoin miners are economically forced to join mining pools. Otherwise, they're just playing a lottery. They're just gambling.
It's forced centralization.
It's forced centralization. And the same thing is happening with Ethereum to a lower extent, but it's still happening. And so if we can give everyone the same APR, the same average APR, then we're kind of allowing solo validators to enjoy this average APR without having to join a pool.
Yeah, to really drive this point home, I would say that I would bring back the concept of MEV spikes, and you can think of, let's say it spikes over the length of 10 blocks. So that first block is 1 ETH, then it's 5 ETH, then 10 ETH, then 15 ETH, then it goes back down 5, 10, 10, 5, 1, over the length of 10 blocks. If you're a solo validators with your 32 ETH, you have like 1 in 600,000, however many validators there are. That's your odds of proposing a block, and then times 10, which is still very low. But if you're a staking pool that has 30% of the stake, then you're going to get on average 3 out of those 10 blocks. So that MEV is going to more likely than not going to the pool. So if you're a rational actor, do you want this variance with this near guarantee of having none of this 10 block spike, or do you want to join this pool and be exposed proportionally to those spikes? So this is what we want to remove to get to a world where controlling X% of the stake gets you X% of all rewards, like, nearly guaranteed.
Dom, that's a great point. Justin, have you coined the phrase to describe this? I see this in our notes prior to coming in, rug pool protection. So not rug pull, but a rug pool. What is a pool that rugs, or a rug pool, and how does smoothing protect us against that?
Right, so this is a third way in which MEV smoothing can improve the security of things on Ethereum. And rug pool is a portmanteau of rug pulling a staking pool. And the way that a staking pool can get rug pulled is by operators. So imagine a staking pool like Lido or like Rocket Pool. You have operators, people can come forward as an operator, and when they come forward, they have collateral. In the case of Lido, it's reputational collateral, but it's also legal collateral, legal liability. In the case of Rocket Pool, you don't have this reputation or this legal liability. You can come in anonymously, but you need to put in financial capital. You need to put in 4 ETH or 8 ETH or whatever it is. Now, let's imagine that an MEV spike comes in, an enormous, a metric ton of bread comes in, and this metric ton is worth more than your collateral. Then what are you going to do? You're going to pick the metric ton and you're going to forego your little collateral, which is your little baguette. And so really, staking pools are in this dangerous and precarious situation whereby whenever a massive spike comes in, they could get rug pulled. And so when you do MEV smoothing, you are actually making it much, much easier to build decentralized staking pools.
So this is also really important for staking pools as a whole. So Rocket Pool, the way Rocket Pool works now with their most recent upgrade, you can spin up a validator, a Rocket Pool validator with only 8 Ether. And then you allow 24 Ether from other people's Ether to come into your validator. And then that's how our ETH is minted. The idea is that you can actually take if you have 32 Ether because you're a solo staker, you can actually split that Ether up into 4 Rocket Pool nodes. But that actually gives you a 4 times larger net to capture the potential 1,000 Ether block that comes in. And so this is actually an exploit attack on something like a collateralized staking as a service provider like Rocket Pool, where somebody can just explicitly come in, spin up as many Rocket Pool mini nodes as possible, and then cast the widest net possible with the intention of rug pooling whenever possible. But now with MEV smoothing, this is a protection against that mechanism. So this is also an economic upgrade for collateralized staking providers, correct?
Exactly, right.
Okay, so what I'm hearing from both of you guys and the benefit of smoothing, the security benefit of MEV smoothing, is basically decentralization. Rather than the birds pooling together in these clusters of birds and becoming like super bird organisms and colluding with each other to get the hunks of bread proportionate.
Being the bigger bird to fight the littler birds.
Yeah, or rather than being the bigger bird with the claws and the teeth to fight and trample over the little birds, we want all of the solo staking little birds to get their share. We want to keep the Ethereum network decentralized. We want to be a collusion, cabal resistant protocol for all the birds out there. So decentralization, that is the big win here in MEV smoothing. In order to get to MEV smoothing, of course, we have to have proposer-builder separation, so PBS included, and then it acts as an oracle, and we're able to identify the MEV, and now we're able to partition it across everybody. So I think maybe we've captured that. You guys feel free to add, but let me tee up kind of the next question. So now don't we get to decide, okay, who gets the pieces of bread? Is it a particular set of these birds? Is it the ducks, or do the seagulls get some too? Or how about the swans? They're very pretty. Which of the birds in our flock, and you guys are protocol designers, so you want to protect the health of the flock, not just the individual birds. So who gets the pieces of bread that we're partitioning out? And I think that gets into this third part, which is burn, redistributing all of the block rewards.
Again, it's a highly parallel with 1559. The way the mental model for blockchains that we had before 1559 was you pay gas fees. This is how much I want to pay to get my transaction in the block. Naturally, that goes to the miner. That was the status quo. And then 1559 kind of changed that into like the miner is getting paid with the block reward. The gas fees is a result of the blockchain providing like a value. So that value really should go to the blockchain. It should not go to the miner, because we challenged the status quo. And then this is what we're going to do with PBS and MEV Burn is today, the natural result, whether we use MEV Boost or not, the natural result is always going to be that proposers get MEV, because at the end of the day, they have a monopoly over the content of the block. And whether they extract MEV themselves or have a side contract with the block builder, they're going to pick the highest bidder always and get this value. And we have to challenge this notion that proposers are entitled to this value, because really it's still value that's being generated by the Ethereum ecosystem, the Ethereum economy on chain and everything. And it goes back to what Ryan was saying earlier, that me and Justin are like RRS agent taxing the economy. There's like two points on that. Is that one is like, it is kind of like a tax, but we want to do it in a credibly neutral fashion. Like just like 1559, we could take the base fee and instead of burn it, send it to the Ethereum Foundation and promise to use that for public good. But we're building a permissionless, trustless system, so we can't rely on having to trust like the tax authorities the same way the US has to trust the RS to properly redistribute this revenue to public goods and everything. Because we're building a network state on Ethereum, and this tax, the most credibly neutral way to do it is simply burn it and redistribute it across all ETH holder and make the Ether asset more scarce to increase security of the blockchain.
Okay, so I want to make sure I'm understanding this. And by the way, Dom, when you said proposers, right? Some people will be thrown off by that. Yes. That is the same as validators. Is that correct?
Yes, because the way I see it, the validator has two responsibility today is to attest, like voting on what they believe the current head of the chain is. And it's all set up so that it converges to one blockchain. And their second responsibility is once in a while, they will be responsible for proposing a block that other validators are going to attest to. Okay. So in the context of block building and MEV, we use proposers.
So proposers equals validators, sort of the same thing. Those who stake, those who run a validator. Okay, so picture this. I refuse to be pulled away from the bird analogy here. So we have a flock of birds. There is one subset of those birds who are actually in the pond. The rest of those birds aren't in the pond, okay? The birds inside of the pond, those are the birds that are proposers. Those are the ones that are validating. Those are the ones that are staking. And so you guys, as the caretakers of the flock, you want to make sure that the entire flock is healthy and supported and decentralized. And so you're saying, well, there are kind of two categories of birds we could give this reward to, this hunk of bread. One is, we could just give it to the birds in the pond, those that are staking, essentially. Or another category is, we could give it to all of the birds in the entire flock, whether they're in the pond, staking, running a validator, or whether they're outside on the edges of the pond, somewhere in the kind of the woods, somewhere else, the entire flock. And you're saying
the mom birds that are still sitting on the eggs.
Yeah, they're doing all the work in the background. Maybe they don't know that
They
there's
need
a
some bread
pond.
too.
Like, they totally need some bread. And so we care about the health of the overall flock here. And so what
entire
was decided,
species.
yes, all the birds, we love them. What was decided by protocol engineers in EIP 1559 was we're not just going to give it to those who are staking. Okay, that would be the equivalent of a transaction fee if you paid kind of the ETH reward in a transaction fee. We're going to give it to the entire flock. And the way you give it to the entire flock in Ethereum, the entire network of birds, is you burn it. Why? Because that decreases the supply for anyone who holds ETH. So essentially, you're giving kind of like a dividend, almost like a burn dividend to like all of the birds in the form of reducing total ETH supply. And so you're saying, Dom, that the choice of MEV burn and MEV smoothing is effectively not to give the MEV just to the birds that are lucky enough to be in the pool and validating and proposing blocks, but you're giving it to the entire flock. How? By burning it. Is that inaccurate, or have we stretched this analogy far too far, Dom?
I think it's fair to say like the economic activity with the value extracted from all the economic activity, in a way, it belongs to no one and it belongs to everyone. And there's a caveat on that is like good MEV versus toxic MEV. Like in the case of toxic MEV, like getting sandwich your transaction, like this is obviously value that's being extracted to one user. So ideally we want to get rid of that and have the user keep that value by getting a good price, which is something we could get into later with the MEV rebates. But in the case of like arbitrage between DEX and decentralized exchanges, this is value that was generated by many, many people. So we can't really give that value back to these individual people. So the next best thing is just to burn it and give it to no one and give it to everyone.
And to be clear, you're just burning all of it. You can't, because
Yeah.
you can't tell the good versus the bad, so you just burn it all neutrally.
Yes, but there are other proposals to get rid of toxic MEV, like encrypted mempools, but that would still keep the good MEV, like being the first in the block to arbitrage all these decentralized exchanges, and that would still be MEV that gets burned and given back to everyone.
The end game is that MEV that originates from a given user goes back to the user.
Yes.
Basically, users have sovereignty over the MEV. And there isn't the infrastructure right now to do the rebates, to do the refunds, but this is coming in a matter of months because multiple companies are working on it. And then once you've removed this toxic MEV and you've kind of rebated it back to the user, all the excess MEV, the latent MEV from arbitrage, this is what we're talking about. This is what we're going to burn.
Learning about crypto is hard. Until now. Introducing MetaMask Learn, an open educational platform about crypto, Web3, self-custody, wallet management, and all the other topics needed to onboard people into this crazy world of crypto. MetaMask Learn is an interactive platform with each lesson offering a simulation for the task at hand, giving you actual practical experience for navigating Web3. The purpose of MetaMask Learn is to teach people the basics of self-custody and wallet security in a safe environment. And while MetaMask Learn always takes the time to define Web3 specific vocabulary, it is still a jargon-free experience for the crypto-curious user. Friendly, not scary. MetaMask Learn is available in 10 languages with more to be added soon, and it's meant to cater to a global Web3 audience. So, are you tired of having to explain crypto concepts to your friends? Go to learn.metamask.io and add MetaMask Learn to your guides to get onboarded into the world of Web3. ARBITRUM 1 is pioneering the world of secure Ethereum scalability and is continuing to accelerate the Web3 landscape. Hundreds of projects have already deployed on ARBITRUM 1, producing flourishing DeFi and NFT ecosystems. With the recent addition of ARBITRUM Nova, gaming and social dApps like Reddit are also now calling ARBITRUM home. Both ARBITRUM 1 and Nova leverage the security and decentralization of Ethereum and provide a builder experience that's intuitive, familiar, and fully EVM compatible. On ARBITRUM, both builders and users will experience faster transaction speeds with significantly lower gas fees. With ARBITRUM's recent migration to ARBITRUM Nitro, it's also now 10 times faster than before. Visit arbitrum.io, where you can join the community, dive into the developer docs, bridge your assets, and start building your first dApp. With ARBITRUM, experience Web3 development the way it was meant to be: secure, fast, cheap, and friction-free.
So I've got Hill Dobby's Dune board up, great Dune board for understanding Ether and Ether stakers. And right now we've got 15.7 of the supply of Ether that is staked to the network. And I think that the philosophical reason as to why MEV Burn is good is simply answered by the supply of people who are holding Ether. So if only 15.7% of all the Ether is staked, that means the supply of Ether that's unstaked is roughly 6.5 times larger than the staked ETH. So when we, instead of giving Ether, the MEV Burn to Ether stakers, and instead we burn it, we are implicitly giving it to all Ether holders. That's a supply of Ether that is 6.5 times larger than the supply of Ether that is staked. Also, the people doing the Ether staking are predominantly Ether whales more than the rest of the Ether. So the people that are owning the remaining 85% of all Ether is everyone else. What Justin called the users, the transactors. And so the mere function of MEV Burn is doing the thing that Ethereum has always been philosophically aligned with, which is maximally enabling the widest and the widest participant, the most marginal person in the whole entire supply chain, and that is the Ether holder. So you, as an Ether holder, are the person that can benefit from all of this robust supply chain, and that is the most accessible part of the Ethereum technological stack. Because even if Ether staking, which has the complexity of this, has been like extremely reduced down to its near theoretical minimum, buying and holding Ether is always going to be easier than that. And so MEV Burn maximally enables the mere Ether holder, the mere pleb of the world who can just hold some ETH.
I mean, most of the flock isn't in the pond, is basically what you're saying. And so it's really cool to be able to like secure the Ethereum network by what? Being a validator is a super class of this, but just by buying ETH. Effectively, you are securing the network, aren't you? That's a pretty big dream for protocol engineers, I'd imagine, because as you were saying, David, what could be more decentralized than the actual distribution of ETH is one of the most decentralized things we actually have in this entire ecosystem.
And Justin, I introduced you as a crypto economic meme lord. When the value of the Ethereum supply chain blockchain does get ultimately funneled to just the ETH holder, what would you say that this does to the legitimacy of Ether, the asset?
Right. So it turns out there's multiple economic benefits that come from burning the ETH, and we could maybe start go through them one by one. One of them is that it actually makes Ethereum run smoother. It makes the economic efficiency of Ethereum go up. And what do I mean by this is that we have this consensus engine which is securing Ethereum, and basically we need less fuel to run it. So right now, the way that we've designed the consensus engine is that with issuance alone, you can secure Ethereum. So anything on top of that, any additional fuel beyond issuance is wasteful. And so right now we're kind of overpaying for economic security. And so we have the opportunity with MEV Burn to run this economic engine more efficiently. Another very important thing is economic bandwidth. There is a possibility that, for example, we're entering a bull run and there's going to be lots and lots of MEV, lots and lots of transaction fees. Now, what will happen in that instance? What will happen is that the rewards to becoming a validator will go up, and more validators will come in, and that will suck all the ETH towards staking, towards securing the base chain, and there won't be much ETH that is available as economic bandwidth to be used as collateral by applications. Now, I believe that Ethereum needs very, very large amounts of pristine raw ETH as collateral for applications, for example, for decentralized stablecoins. We want to have trillions of dollars of decentralized stablecoins, and we don't want all the ETH to be sucked out for staking, because that's not the most utilitarian, the most useful way of allocating Ether. Another very important thing is around economic sustainability. So right now, the sustainability of Ether, the asset, hinges on one single business model, which is congestion fees. And there is a possibility that this business model will get eroded or jeopardized over time. And the reason is that Congestion only happens if there's more demand than there is supply. But we live in an exponential world with technology, right? We live in a world where supply grows exponentially. There's this equivalent of Moore's law for bandwidth, which is called Nielsen's law. Nielsen's law says that every year, consumer bandwidth grows by 50%. And so if we have this exponential growth of demand, of block space supply, then we might essentially have infinite supply and the congestion fees will go to zero. Whereas contention is something that's kind of always there. It's latent. It derives from these market inefficiencies that can be arbitraged out. And so now we have these two business models. If one of them fails, it's maybe okay because the other business model comes in.
That's really fascinating, that business model idea, Justin, because one thing we've tried to reinforce on Bankless when people are trying to understand blockchains is what products do blockchains produce. And we always say this: blockchains sell blocks. That's the product that they actually sell.
Blockchains sell blocks.
Yeah, and we've compared it to sort of like Apple, right? So the value of an iPhone is worth more than sort of a commodity phone. You could see that in the profit margin. So Apple sells really good phones, and so they're able to charge a premium. That's why there's a premium on Ethereum block space. But what's also interesting is this idea of a second business model here. If you notice, a company like Apple, their first business model is they sell the phone, they sell the hardware, they make $1,000 a phone. That's fantastic. They also have other business models, one of which is like App Store, 30% tax on everything. And that's their second model kicking in. And you're implying something similar to Ethereum. Of course, a little bit different, not the same mechanics, but its first business model is congestion. Second business model is contention. And you're kind of able to sell both of those products to the highest bidder. That's a really cool way to look at the economics of this thing that we're building, to understand back to what is the fair market value of ETH, which is what the market is trying to figure out. This is primary information that goes into those valuation mechanisms. I just wanted to make that point. I think you had another comment on this as well about the benefits.
Right. I mean, we can try and quantify, what are the benefits of adding this second business model running in parallel with the first business model. And the way that we can quantify that is by just asking ourselves, how much more burn would we have had we had MEV burn? And the answer is on the order of 250,000 ETH per year. And that's during the current conditions, kind of the bear market conditions.
Wow.
But actually, the story gets even better, because remember how I was saying that by burning the MEV, you actually have a more efficient consensus. So that means that you're issuing less. You have to issue less to pay for security, because the more validators come in, the more issuance there is. And that is a roughly 200,000 ETH improvement over the status quo. So we have two benefits to MEV burn. The first one is that we'd be burning on the order of 250,000 ETH per year, and on top of that, we'd be saving 200 ETH that we wouldn't be printing, that we wouldn't be issuing. So roughly speaking, it's a 500,000 ETH per year optimization that we have as an option.
So MEV burn is 500,000 per year optimization?
Yes.
Okay, so I've got ultrasound.money. That website is up, made by Justin Drake here. So the man right in front of me. The merge happened 230 days ago. And we have burned 135,000 Ether. I am famous on Bankless for being terrible at math, but I think that means we are roughly 2/3 through the year. So if I multiply 135,000 by 1.33, we get to 180,000 Ether that is burned under an EIP1559 paradigm post-merge. And so you're saying that MEV burn is going to burn an additional 250,000 on top of that.
Yes, the net supply will decrease by another 250,000. So it will roughly double the speed at which the supply would go down. That's only including the burn. But then if you include the savings from issuance, it will actually triple the speed at which the supply has gone down. And the reason is that the issuance, there's a saving of roughly 200,000 ETH per year. So if we had MEV burn right now, we're we would have decreased the supply by roughly 400,000 ETH instead of only 135,000 ETH.
Wait, can you explain the mechanism of we actually have to issue less Ether? Maybe I missed that part. Can you explain that?
Right. So there's two rewards for the validators. The first one is issuance, and the other one is MEV. And so the higher the MEV, the more of an incentive there is for validators to come in. But the more validators there are, the more issuance there is, because the total amount of issuance grows with the square root of the number of validators. So if we remove MEV from the equation, we only have the number of validators that is required to secure the chain and no more. There's no wastage from a issuance standpoint.
So the net effect of MEV Burn will actually be a transfer of wealth from Ether stakers to Ether holders. And so there will be a lesser incentive to stake Ether because the yields to ETH staking will actually go down. But everyone knows there's a reciprocal relationship to yields and principal value. The idea is that the yields to ETH staking will go down. It will fall probably down to the rate of Ether issuance, the yield from Ether issuance. And therefore, the supply of ETH stakers will go down. But that's because we're going to burn more Ether. So in theory, the reciprocal relationship of principal to interest goes down, principal goes up. And what is principal other than the value of Ether? That's my understanding. Is that correct?
So there's actually some subtle things going on. And one of the very common question that I get is MEV Burn to the detriment of stakers, right? Because we're removing one of the incentives to become a staker. And so you'd think that maybe your APR as a staker will go down. Now, my response to that is that no, it's actually not only is not to the detriment, but it's to the benefit of stakers. But I need to kind of make my case. So in an efficient market, the rewards for staking will tend to the cost of money. What do I mean by that? When you're staking, you have various costs. You need to run a node, you need to pay for the bandwidth, you need to pay for the electricity, but you also need to pay for what's called the opportunity cost of ETH, right? Because you're taking this ETH and you're locking it in a black box, and you could be locking it in a different black box. For example, you could be putting it in DeFi yield somewhere and getting some percentage. And so there's this concept of the opportunity cost of money. And by far the biggest cost when you're staking is the opportunity cost of money. Now, let's say that the opportunity cost of money is 2%. Well, what will happen is that organically, the staking yields will tend towards 2% in a competitive market. And the reason is that the margins go to zero. Now, whether or not there is MEV burn, the rewards will tend towards the cost of money over time as an equilibrium. So from a ETH denominated standpoint, you get the exact same percent. So if you have a 2% cost of money, you should expect that every validator gets 2% of 32 ETH, which is 0.64 ETH, regardless of whether there is the burn. But now let's think from a USD denominated standpoint, right? Because the burn increases the scarcity of ETH. It fuels this value in the price of ETH, and so the price of ETH should go up. And so, as a staker, you're actually making more returns from a USD denominated standpoint. Now, the other thing worth mentioning is that for the average validator, as I mentioned, we're all kind of losers, and there's a few jackpot winners. And so, not only are we increasing the returns from a USD perspective, but we're also moving the mean up moving the median up to the average, which increases rewards for everyone. And there's this additional thing which I mentioned is that if you're participating in a pool, then you won't get rug pulled, and so again that will increase your APR.
Okay, so like rawly intuitively, we're taking away yields from Ether stakers and we're burning it, giving it to Ether holders. Yet Justin is still saying that the yields are going to stay the same. And the way that the mechanism that you're saying that this is happening is that the incentive to stake is actually going to decrease. And so people will unstake because they're actually getting some value of the Ether burn anyways by not staking, by just being an Ether holder. And so then the issuance, the yield that you get from staking will actually increase because this is what happens when people unstake their Ether, yields go up. And so you're saying that fewer people will stake, but yields will stay the same. And so maybe if we're going from like 30% of Ether staked to just 20% of Ether staked, yields are still going to be the same. But okay, so it's a net loss to stakers as like a system, but individual stakers are still getting the same yields that they already were prior. Is that correct?
Yeah, that's correct. So as a system, there's less ETH that goes towards rewarding all of these stakers, but from an individual standpoint, it's the same. But one thing worth mentioning is that, usually when you're running a staking business, you think in US dollar terms. So if you're Coinbase or if you're Lido or whatever, you're going to take a fee which is kind of USD denominated, and it's possible that the increase in ETH price is going to more than compensate than the loss of Ether that you're going to collect. And so even for services like KRAKEN and Coinbase and Lido, it is to their benefit, likely from a USD denominated standpoint.
Okay, Justin, so I want to ask you a question. You put out some numbers there. I'm trying to assess the magnitude of the impact that this could have, right? And putting on the investor cap, because every time we have Justin Drake in the podcast, this time aided by Dom, I learned something new about Ethereum and this asset that I hold. And I bet a lot of Bankless folks listening will be learning something about ETH today. And we're learning that there is this new business model that is going to start burning ETH, a new furnace to like the ETH burning scheme that is going to be added with MEV smoothing and MEV burn, right? In addition to EIP 1559. And since we actually conducted the merge and we migrated to proof of stake and we received the issuance reduction from proof of work to proof of stake, and the net impact of EIP and the move to proof of stake, we have burnt Ethereum's ultrasound up to a total of about 120,000 ETH, right? And that happened, of course, last September 2022. If we had MEV smoothing and MEV burn in place since September 2022, let's say, if that mechanism was on as well, we had not only the first furnace, but the second furnace, how much do you estimate, how much ETH would we have burnt? Because I heard you say something in the number of 450,000 per year. And so I'm kind of doing the math, and that seems like it's about like 3x the amount of issuance decrease. So this second furnace, I'm trying to gauge the order of magnitude, is maybe like a 3x increase in supply or decrease in supply. Give us that number again. So what do you think? If we're 120 since September of this year, how much would we have been if we had the second furnace activated, do you think?
Right. So since the merge 229 days ago, according to ultrasound.money, the supply has reduced by 136,000 ETH. Now, if we had MEV burn, the supply would have decreased by roughly 3 times faster. So we would be right now at minus 400,000 ETH. And the reason is that there's 2 things going on. On the one hand, we would be activating this new furnace, which would burn on the order of 250,000 ETH per year. But this is very volatile because it depends on the conditions of the market. This would be assuming kind of the last few months of conditions, which has been a bear market. So it's kind of a conservative assessment. But then there's this other thing that kicks in, which is that we would be potentially reducing the total amount of ETH staked and thereby reducing the total amount of issuance, and thereby making it also easier for the supply to go down, simply because we're not printing as much, we're not issuing as much. And so that would kind of add on top of the burn, and net, roughly speaking, we're talking about a 3x speed up in the speed at which the ETH supply goes down.
So let me translate that into some annualized percentage numbers. So since the merge, Justin, we have been about kind of an annualized supply reduction of 0.179%. How with MEV burn would be like 3x that number, something along those lines?
Right. So roughly minus 0.5% annualized.
Okay. So this is another burn mechanism, which is going to make ETH more deflationary. So I look at that with kind of my investor hat. One question I have for you, though, is it bad for ETH to get too deflationary? Like, are you guys a little bit worried as kind of IRS agents and kind of the protocol researchers here, that what if we make ETH too ultrasound? What if it becomes too deflationary? Is that a concern at all?
Right. So I guess there's two answers here. Like, one is that the deflation eventually ends. So what happens is that there is this equilibrium where eventually, the supply is constant. So for Bitcoin, right, there's this equilibrium on the upside. The Bitcoin supply will grow roughly for the next century, but the BTC supply will inflate, and then eventually it will reach 21 million. For Ether, it will be the opposite. For the next century, it will go down, and then eventually it will reach an equilibrium. What this final equilibrium is depends on economic activity and also as to whether or not we enable the MEV burn. But it's going to be something between 50 million and 100 million ETH. So the total supply of Ether, roughly speaking, ballpark figures, should decrease by a factor of 2 over the next century, and then eventually we reach this equilibrium. But the other thing worth mentioning, I guess, is what does it mean to be money? And what are the various uses of money? And the way that I think about it is that there's basically two types of money. And maybe we should be using different words because it's confusing to be using the same word. So on the one hand, we have currency. Currency is this money that flows in a system. It comes from the word current, and it's used as a medium of exchange. And you want your currency to be non-volatile, to be stable, and to be very easy to move around. And the way that I think we will build currency on Ethereum is through decentralized stablecoins. So you're going to put ETH as collateral, and you're going to stabilize ETH, kind of create this synthetic asset, this debt. And so on the one hand, we have this currency, which is a debt asset. And it's kind of good if this debt asset it goes down in value over time, because if you have a loan, for example, on your house, like if the value of the asset keeps on going up and up and up, it makes it more and more difficult to repay your loan, and you might default on your house. So you kind of want these debt assets, these currencies, to kind of go down in value, and that lubricates the economy. On the other hand, you have a different type of money. You have collateral assets, things like gold, for example, or things like property. These are used as collateral against which you can take a loan, or against which you can draw currency. And here is the opposite mechanism. You want the value of your collateral assets to go up over time. And the reason is that this reduces the risk of default, right? So if you go on Maker, you deposit ETH, you draw some DAI, and the value of your ETH goes down, then you're at risk of being liquidated. But if the value of your ETH kind of as a trend goes up and up over time, then that makes it the perfect collateral asset. And my thesis is that Ether is the collateral asset, the collateral money for the internet of value. And it has two main use cases. On the one hand, it's a collateral asset for staking, and it secures Ethereum as a settlement layer, as a platform. But the other very important use case is that it's economic bandwidth. It's collateral, it's money that is used by application, that is consumed to create things like decentralized stablecoins that will be the currency for this internet of value that we're creating.
I would like to add a little illustration to that. Like with the idea that your property is collateral value. Like let's say you take a loan against your property, against your house, and you want the loan to be inflationary and easier to repay over time, because that allows you to, for example, improve your property and increase the value of your property to unlock more bandwidth to let you take a bigger loan and keep improving it. It's like a feedback loop. And it's very simplified, but it's the same thing should happen with DeFi and Ethereum as collateral. So let's say you take a stablecoin loan with your Ether as collateral, and then your stablecoin loan lets you go in DeFi and do arbitrage or do all sorts of things. And that gives you value. And also that's increased economic activity on Ethereum, on the broad Ethereum economy. And which generates MEV, because whatever you do, the more economic activity, more MEV there is, which burns more ETH due to MEV burn, which increase the value of your collateral. So there's the same feedback loop happening where it's very lucrative to just hold ETH as collateral, and the lesser the incentive to stake, we don't have to go through a liquid staking that has additional risk both for yourself and the broader system if everything relies on one liquid staking operation.
So I guess in the answer to the question of like, can ETH be too deflationary? Your answer to that, Dom and Justin, is no, it really can. I mean, the more deflationary it is, it makes it a worse currency, but a better store of value, a better money, if you will, a better, richer source of economic bandwidth. It actually expands the economic bandwidth. So I think maybe that question is almost wrong. It comes at the question from the wrong perspective of what ETH is trying to do. It's not trying to be a currency, a general currency. It's trying to be a store of value monetary instrument for the entire crypto ecosystem and the internet internet. It's an important distinction.
I think it's also important to zoom out and view the Ethereum economy from a systems perspective. Justin here likes to say that perhaps the killer app of Ethereum block space is stablecoins. And so we are seeing a very intrinsic relationship between Ethereum and stablecoins and fiat inflationary units of account. So this is the idea that we have this yin and yang, this deflation and inflation, and the deflationary asset will naturally be chosen by economic agents to be the collateral to be borrowed against by inflationary assets. And the whole idea that Justin incepted in my brain way back when, I think in the Ultrasound Money episode itself, the idea of sci-fi economics, where we have these financial positions. In aggregate, degens will get liquidated. They'll put Ether into Aave. They'll pull too many stablecoins out. They'll get liquidated. But in aggregate, Ether will be the collateral. The stablecoins will be the borrowing unit of account. And the economic zone of Ethereum will have tailwinds that no other economic zone in the world will have because of the deflation of Ether, in contrast, juxtaposed by the inflation of everyone's unit of account. And so just the economic investability, the downstream wealth effects that creates around DeFi and the rest of the Ethereum economy are going to produce some sort of motor on the Ethereum economy that no other economy has. And so that's just the very bullish vision I have for the Ethereum economy. Justin, any reflections on that?
Yeah, I agree. And there are some very strong network effects around this idea of monetary premium. So how do we achieve monetary premium? We achieve it by creating sharding points. We achieve it by somehow convincing society that one specific asset is special, right? Society has successfully deemed gold to be a special asset, and that has given it monetary premium on top of its raw utilitarian value. Now, why do I talk about monetary premium? I talk about it because it is absolutely necessary to get to this point where we have trillions of dollars of decentralized stablecoins. Right now, we have centralized stablecoins, and they're on the order of $100 billion. And my thesis is that centralized stablecoins are not going to scale very well to trillions of dollars. And the reason is that if you have a centralized stablecoin, you're going to need to spread out those trillions of dollars over multiple banking partners. And you just need one banking partner to fall through. And then that leads to a haircut, and that leads to a loss of confidence in your system. So yes, Tether was able to scale to roughly $100 billion. Will it scale to $1 trillion? I don't know. On the other hand, decentralized stablecoins are meant to be rock solid. And if we can find a way to scale them to trillions of dollars, that will really help Ethereum reach its ultimate vision. But how do we get trillions of dollars of decentralized stablecoins? Well, we're going to need trillions of dollars of pristine collateral. And the only way that we get there is if we somehow create this sharding point that Ether is money for the internet. And there's various things that are important sharding points in the context of money. One which is absolutely critical is economic security. Like how many billions of dollars are currently securing your blockchain? What is the cost of attack to do a censorship attack or to revert a finalized checkpoint, etc.? And already today, Ethereum is the most secure blockchain by that metric by a factor of 4. The other very important thing is this idea again of economic bandwidth. And as Dom said, we have this positive feedback loop going on, because the more economic bandwidth we have, the more decentralized stablecoins we have, the more economic activity we have, the stronger the shelling points become of scarcity and security. And so, yeah, there is this very strong bull case that there is going to be, in my opinion, one asset that's going to win the beauty contest, basically, of being the most attractive asset. And right now, Ether, the asset, is the number one, contender to winning this beauty contest.
Bitcoiners, look out! Watch out for that one.
I think we've long moved past Bitcoin, but I guess we still have to move past in market cap. Dom, I want to throw this quick question to you just to make sure we check this box. 4844. How does MEV Burn and 4844 interact? How do these things relate to each other?
It's a bit tricky at this point, but the way 4844 is going to work is by splitting the two markets for execution and the market for data. And execution is going to be the same. So there's still going to be MEV happening at layer 1 as these whales and large institutions have to settle value in exchange on DEXs on layer 1, because currently it's still the most secure layer. And in my opinion, it's going to stay the most secure layer, even if there's layer 2 are going to become more decentralized and more secure over time. You're still going to want this fallback to layer 1 execution, which for many reasons, it's going to keep being congested and unscalable. So there's still going to be a lot of activity and congestion fees on layer 1, while a lot of stuff happens at layer 2, which uses data, which with the 4844 and Dank sharding is going to be much, much cheaper. So this is the idea that data is very easy to scale at layer 1, and it's gonna bring down the congestion pricing relating to data. But the way it works with MEV and layer 2 is depends on how the layer 2 is set up, because one of them, like Optimism, can capture congestion and MEV by having one sequencer or many sequencers each taking turns at batching data to layer 1, and they can capture that MEV at layer 2. But the way it can work plausibly is by having what Justin coined as based rollups, where the sequencing is completely permissionless at layer 1, so there's still going to be some competition between many layer 1 builders to create the best layer 2 block to post on layer 1. So that's going to not only bring more liveness to the layer 2 rollup, but it's also going to bring back the MEV to layer 1. All the economic activity happening at layer 2 is going to generate layer 1 MEV, which with MEV burn is going to end up being burned.
Justin, at the very beginning of this podcast, you were using the metaphor of just regular old gasoline that powers cars, but then you have highly refined jet fuel that powers jets. I want to throw a version of this metaphor into the hat and see if you like it. So we have the Ethereum economic engine. 99% of the thrust gets powered by the combustion engine and regular old gasoline, but that 1% of the contention slot, the contention side of this engine is actually a supercharger. And the way that a supercharger works is that it's a fan that's connected to the combustion engine. So the combustion engine's crankshaft is connected to a fan belt, which spins a compression fan that compresses oxygen and then throws that into the combustion engine. And that allows for a more efficient burning of gas. And so you got the normal Honda Civic that's got the combustion engine, but then you've got the supercharger on top of it, which just makes sure that the gasoline is juiced up to the max. I mean, I'm throwing that metaphor your way, seeing if you like it.
Yeah, I love it. So basically, you're taking this really high octane, high density fuel, and you're combining it with this, oxygen, which is compressed, and then you're pushing the two together, and you're you're running this extremely sophisticated engine, which is performance critical, mission critical, ultra low latency. MEV game is kind of a game where every millisecond counts, and you have the armies of PhDs and very sophisticated players coming in. Now, one of the things to continue on this metaphor that you bring up is the exhaust. So in Ethereum, we have basically sell pressure, which is taxes. So in Bitcoin land, the sell pressure comes from having to buy electricity and buy mining rig, but in context of staking, it's taxes. And you can kind of think of that as kind of pollution or like a negative externality that you want to try and minimize. And it turns out that MEV Burn, in addition to being this roughly 500,000 ETH per year optimization, is also a tax optimization which dramatically reduces the sell pressure of
We're talking about
Ethereum
nation-state taxes here, Justin.
Yeah, we're talking about normal taxes now.
Yeah.
Exactly, yes. And maybe the best analogy is with stocks. So there's this one weird trick with stocks, which is that if a company has $1 billion, let's say you're Apple, you have two options to redistribute this value to the shareholders. Option one, you can issue dividends. So you give $1 billion of dividends across all the shareholders. But what happens is that these dividends are treated as income tax. Now, in many jurisdictions, income tax is, let's say, 50%, just as a ballpark figure. And so you have sell pressure of $500 million. But there's this other thing that you can do, which is you can do a share buyback. If you do a share buyback, this $1 billion basically translates in the total supply of the shares going down and the price of each share going up by a commensurate amount. And now you're taxed in capital gains tax. And in many jurisdictions, capital gains tax is significantly lower than income tax. So for example, in the UK, capital gains tax is roughly 20% and income tax is roughly 50%. And so we have this, roughly speaking, 2.5x tax optimization, which will decrease the sell pressure, the forced sell pressure that the stakers have when they're participating in the system. So if we have 250,000 ETH per year of MEV today, well, roughly half of that is going to be sell pressure. So 125,000 ETH is going to be sold. But if we instead kind of funnel everything in capital gains tax, then it's only going to be 20%. So there's only going to be 50,000 ETH of forced sell pressure.
Another hidden benefit, another byproduct of this. Justin, Dom, this has been super helpful for the Bankless community. Just a few lightning round questions for us. Okay, so we're talking about futures here. And as we know, it took a very long time before we started talking about EIP1559 before to actually shipped into production. When is this coming? Roundabout. I know there's not a fork where it's like, well, it's then the next hard fork, but just rough range. Are we talking like, is this like 2 years out? Is it 3 years out? Sooner than that? What do you think, Justin and Dom?
I would say it's on the 3 to 4, kind of maybe 5 year time frame. And one of the meta points that I want to bring up here is, why does it take so long for us to do these things? And I guess one of the answer here is around the policy that we have as a community, this implicit policy, right? So Bitcoiners as a policy have this idea of maximum ossification. And I think for Ethereum, we have this idea of continuous innovation and improvement. And that's kind of expressed in this minimum viable issuance policy, which could be restated as maximum viable scarcity. So when Ethereum launched, the best that we knew how to do in terms of securing the chain was to issue 5 ETH per block. And then we realized that 5 ETH per block is way too much. We can reduce it to 2 ETH per block or 3 ETH per block. And then we realized we could reduce it even further to 2 ETH per block. And then we realized we could do this really fancy optimization called proof of stake. And now it's only a quarter of an ETH per block. And then we realized that there's this other thing that we can do, which is EIP1559, which burns, which so far has burned 3.1 million ETH since EIP1559 was launched, which is a massive optimization. And now we're talking about yet another thing that we've unlocked. If you had asked me a year ago, is there any further improvements to Ethereum? I said, I'm not sure. But actually, we kind of discovered this new thing just through research and innovation. And it makes sense to integrate it in our roadmap because it's part of this maximum viable scarcity policy that the community has adopted. And if you were to ask me, okay, is there something else maybe in the pipeline? I would say yes, there is something else, maybe even beyond MEV Burn, and it's this idea of capping the active validator set. So right now, in theory, what could happen is that almost all ETH could come and become stakers, and that would lead to on the order of 2 million ETH per year of issuance. But if we cap the total amount of active validators, for example, to 33 million ETH, then we would also de facto be capping the total amount of issuance to roughly 1 million ETH per year. So that is kind of a further potential improvement going down this road of minimum viable issuance and maximum viable scarcity.
Yeah, that's right. I mean, that has been the social contract of Ethereum all along, is what is the monetary policy? It's minimum viable issuance. And so all of these improvements contribute towards that. So, well, thanks for giving that kind of like timeline estimates. We're talking about this as a more distant improvement. PBS, some other protocol changes have to happen. This might come into play 3 to 5 years down the road. I remember when I started learning about EIP1559, and that was in, I believe, 2019. It took about 2.5 years for that idea to actually get executed and deployed. This might take that and a little bit longer to get out there, but is super exciting. Nonetheless, I learned a lot. What do birds and oil and digital money all have in common? I hope you learned that in the episode as well. Dom and Justin, thank you so much. It's been great to have you.
Thank you, guys.
Thank you, guys.
Bankless Nation, of course, we just had 2 big brain protocol researchers on the episode today. So you might have some questions about some of the terms that we bandied about. MEV, what is that exactly? Fortunately, Bankless has done an in-depth series on MEV. We will include a link to the episode you need to go look at in the show notes here. Also, if you were thrown off by the question from David to Dom about EIP 4844, and you're like, what does that mean? We have episodes about that too. So catch that in the show notes. Of course, gotta also refer you to the classic Ultrasound Money Chronicles. This is a series of episodes Justin came on for, and I think this was 2021 or so. And we will include a link to that when we were first talking about this concept of ETH as ultrasound money. This episode, it feels like, was just an extension of that episode that we recorded 2 years ago. My, how time flies. Also, need to remind you, none of this, of course, has been financial advice. We have no idea what the future price of ETH is. All crypto is risky, but we are headed west. This is the frontier. It's not for everyone, but we're glad you're with us on the Bankless journey. Thanks a lot.